All right, we are underway here. This is Learning with Mr. Neff, and we're going to talk about exponential functions, really help you understand it today here. Now, I will tell you, let's start with a little story here, okay, to help understand this. Now, there was a king, a mighty king, a rich and mighty king. He ruled his kingdom mightily. He had a princess, a beautiful princess. So one day, this beautiful princess was snatched away by a greedy and grumpy troll. Yes, this troll stole the princess and then demanded him to turn over his kingdom to the grumpy troll because he was unhappy. But the king offered a reward to anyone who could rescue his princess. And of course, a lowly and mighty and intelligent peasant rescued him. Yes, that's a good-looking peasant right there with great-looking hair. Rescued the princess from the grumpy troll. And so the king was very happy and offered him a reward. He offered him $1,000 a day, every day, for a year. Now this peasant, although poor, was not unwise, and he thought, that's not a bad deal. But he proposed, I don't need much. How about you give me a penny today? And then tomorrow, you give me double that, 2 pennies. And then the next day, and do that for 30 days. That's it. So the king thought about it. He's like, wow, just a penny? Well, you sure? And he said that the peasant said yes. All right. And so who got the better deal now? All right. Well, the first one is what we call a linear model. $1,000 a day every day for years. The linear model. Every day you get $1,000. So tomorrow you're getting $1,000. The next day $1,000. Pretty good. There's your equation. Y equals 1,000x. Your slope is 1,000. And 365,000 after a whole year. Pretty good. Could probably live and retire pretty comfortably. We may not retire, but live pretty comfortably at $365,000. Now, what about the doubling? That's not a linear model because we're not adding the same thing every day. We're multiplying by 2 every day. So that's an exponential model. And lo and behold, the equation will look something like this, where you start with 1 penny, and then you double it every day, 2 times it was the day before. So 2 cents, then 4 cents, and then 8 cents, and then 16 cents, and so forth. And not very good deal for the lowly peasant, except for let's put in 30 into that function. On the 30 there, 30 days, right? And so we plug, and guess what we get? $10,737,418.24. Now, that's just day 30. So exponential growth, who do you think got a better deal? That lowly peasant isn't so lowly now. And the king, hopefully lowly peasants moved far away, because I think when the king figures that out, he'll not be too happy with the lowly peasant. So understand the difference between linear models, all right, and exponential models are very important, and that's a very good distinction. So that's what we're going to focus on here. Evaluate graph exponential functions. An exponential function, again, repeated multiplication shown through exponents. So linear model is repeated addition shown through multiplication. A exponential model is repeated multiplication shown through exponents. All right, and A is the initial value, and then B is the repeated value, what you're doing each time, repeated multiplying value. Okay, and X is your unknown. You don't know how many times, 30 days, 100 days, whatever it was, that's what it would be there. Okay, so that's what we just said. Some functions model initial amount and repeatedly multiplying the same number. The independent variable becomes your exponent here. That's how you know it's an exponential model there. All right, so let's just look at an example what is the graph of 2 times 2 to the x? So if we're going to graph, we're going to make ourselves a table. Fortunately, we can put this in here real quick. We plug in a -2, we get 1/2. Plug in a -1, we get 1. Plug in 0, we get 2, because remember, anything in the power of 0 is 1. And so there's our model, and when we plot our dots in reverse, okay, there you see the model. That is, and you can even put some arrows on it to show that model. Will it ever touch this line right here? No. Will it curve back up? No. It's just going to get limits. The idea of limits is it approaches 0, but it'll never quite be at 0. Okay. Let's look at, now here is just an evaluate. So here we have a function right here, and then they're giving us a value, and same here. So first one we see there, and then the second one as well. We're going to plug in the value into the exponent. So the first one here, we plug in the 3, and then we'll do 2 to the 3rd power, and we get 8. And then 6 times 8 is 48. So the function of 3 in this is 48. The input is 3, the output is 48. In problem 2, we have 45 times 3 to the w power, and w is -2, they said, so we plug it in there. 3 to the -2, remember 3 squared is 9, so 3 to the -2 is the inverse of 9, which is 1/9. And 45 really divided by 9 is 5. Okay, that's example 2. All right, here is a word problem. All right, and then I will get into, the next video will get into understanding how we write these more. A solid waste disposal plan proposes to reduce the amount of garbage each person throws out by 2% this year, by 2% every year. This year, each person threw out 1,500 pounds of garbage, so they want to reduce it by 2% every year. Now, does that mean in 2% every year, does that mean in 50 years it's going to be at 0? No, this is exponential. The easiest way to understand that is if I reduced it by 50%, would it be gone in 2 years? No, you reduce, if you had, let's just say 1,000 after 1 year, then reduced by 50% would be 500, and then it'd be 250, and then 125, and so forth. This model here is reducing by 2%. That means 98% would be left every year, and so they want to see that model, and so we're going to graph that. Now I have one here that somebody had made this PowerPoint for me. Now notice what they didn't do is they didn't go start at 0, and so you only see part of it. It looks almost like a linear model. I went to Desmos.com and I was able to go there and put in the equation and then see the whole thing. Notice it starts at 1,500, and there after 2% after 1 year, you see it going down, but eventually it's going to get closer and closer. It's never going to touch it. So I mean, you're basically, after 250 years, you're basically at 0. Now, is this realistic? Probably not. But it's the idea that that would be an exponential model of the amount of garbage over time. All right, so it was decreasing, it was going down. Now, if this number is greater, all right, if this number is greater than what would make it go up? Greater than 1 will make it go up like this. All right, that would be an example of being growing because it becomes a growth factor, which is the next video that we'll talk about. One more thing to look at here then is how can we use graphs to help us come up with a solution? All right, so what is the positive solution to this right here? All right, so this is really more of a graphing calculator thing that you would do. We want to know what x is. So what we're going to do is we're going to create two functions. The left side, see this is the left side, we're going to graph 2 to the x. And then the right side, we're going to graph 2x plus 2. So we graph 2 to the x. There you see it right here on the graph. And then 2x plus 2. All right, if I put this in a graphing calculator, this would come up like so. This is actually really nice, student who did this. And then we see where does it cross. It crosses right here. And there's our grid, which should probably have been there to start. And it crosses at the point 3, 8. All right, so what is the solution for x? X is 3. How's the 8 play into it? Meaning, well, if I get 2 to the 3rd, I get 8. 2 times 3 plus 2, I get 8 as well. So the left meets the right. They meet at 3, 8. They actually meet here as well, which is like at negative 0.62, 0.69. All right, so if you were asked to give both solutions, I believe that's what it was for that. Okay, I just wanted the positive solution here. This one we're saying is irrelevant. A lot of times in word problems, that negative solution is irrelevant. But notice it does cross twice in this linear model here, the linear and the exponential together. But that's how you would do that. You would graph this one separately and then this one separately. Almost think of it as y equals and y equals in your graphing calculator, and you're just finding the intersection. So in your graphing calculator, I'm not pulling it up right now, you will look to find the intersection of that. All right, you would calculate the intersection. And again, if you don't have your graphing calculator at home, you go to desmos.com, and then it's very user-friendly. And after a little bit of work, you'll start to figure that out. Okay, that's all we really have right now on exponential. I hope you enjoyed the story and the learning with Mr. Neff. Have a great, great day.